we focus on the second layer. Okay, the second layer is the data link layer. Okay, in the data link layer, just deal with the data sending from one computer to another directly connected computer. Okay, one device, maybe this is a router, it's the same. Okay, the router is the same. And then one router to one another directly connected router. Okay, this is the data link layer's function. Okay, data link layer. Okay, in the data link layer, of course, most widely used is the Ethernet. We focus on Ethernet. In the data link layer, we just adding a header and then adding a trailer. Okay, we have described the trailer is used to check if the data is correct when data is communicating between these two computers. And the header, yeah, contain address that to decide just host B or other host should receive this. Okay. And then we see the detailed contents. Okay, in the previous slide, this is a frame, this is a header, and this is the trailer. Okay, and then trailer is the checksum. Okay, the frame checksum. Okay, frame checksum to verify if this frame is correct when standing between these two computers. And the header, okay, there are two formats. One format is the Ether2. Ether2. Okay. Of course, the Ether2 also is the most widely used format in nowadays Ethernet. Okay. The Ether2 is also known as the DIX Ethernet. The DIX, this is the three companies names abbreviation. Okay. D means the backnet, I means the Intel, and the X means the Xerox. Okay, this DIX format. And then in this header contain three fields. One is the destination MAC address, and the second is the source MAC address, and the third is the type. Okay, the destination and the source MAC address means to identify the device. The MAC address is the address, that's the hardware address, we call hardware address. That is bound into the NIC card, that's the network interface card. Each network interface card have a MAC address. So here, when the data is sending from host A to host B, then the source MAC address just the host A, and then the destination MAC address is host B. Okay, then the host B's network interface card bound-in address, okay, MAC address, and then the type. This type field is to identify what data is contained in the upper layer. As we know, in the layer 2, this is the Ethernet link. Then the physical device will know this is the Ethernet network. But what is carried in the Ethernet? As we know in the reference model, Ethernet can carry many different protocols. The IP protocols, the IPX, the Novel's IPX protocols, and the IBM's protocols. Then how to identify this? Just use this type field. Okay, this type field to identify what protocol, what type of data is carried in upper layer. Okay, this is Ether2. Okay, and then there's another format we called IEEE 802.3. Okay, 802.3. Okay, in this frame, the destination MAC, source MAC is the same, but the stored field is the length. Okay, they are both 2 bytes long. Okay, 2 bytes long. That's also 2 byte. 2 byte. And then there's the upper layer protocols, upper layer data, and then FCS is the same. But then here arises a problem. When the computer receives the frame, then how do this compute to identify if this is an Ether2 frame or this is a .3 frame, 802.3 frame? How to identify this? So there's a specification. In the Ethernet specification that says the longest length of the frame should not over this length. Okay, of course, but the upper layer should not over 1500. Okay, this we call MTU, maximum transmit unit. Okay, so the field value, if is smaller than this value, smaller than this value, should be the length, because the frame not longer than this value. Okay, and the type value, the Ether2, when specify the type value, should be bigger than this value, and the value smaller than this will not assign. It's used as the length. So when the data is sending from one host to another host, then the host receives it, then looking into this value. If this value is small, smaller than 1500, then it's the length, and this frame is this format. Okay, so use this format to corresponding to each field. Okay, and then if the value is bigger than this value, 1536, then this is Ether2. Then this field will regard as the type. Then we'll know what is the upper layers protocols. Okay, this is the 2 type of Ethernet frame. We should know there are 2 types, and then how to identify each of them. Okay, then first we discuss the Ethernet 2 type. Ethernet 2 type frame. In the Ethernet 2 type frame, there's source destination MAC, source MAC. This is a 6 byte. MAC address is 6 byte long, and then the source MAC is also 6 byte long, and then 2 byte type. Then the type is used to identify what data is carried in the upper layer data. Okay, and of course the length should be this range. Okay, then there are 2 examples. This value 0800, this value means the data carried in upper layer is an IP packet. Okay, it's an IP packet. And this value 0806 means the data carried in the upper layer is an ARP protocol. Okay, and then there's FCS. Okay, FCS. And we can see both these values are bigger than 0600. Okay, it's a bigger value than 1500. Okay, this is the Ether2 frame. Okay, and then there's a IEEE 802.3 frame. Okay, in this frame, the source field, the previous 2 is the same, and then the source field is the length. Okay, is the length. The length is 2 bytes long, And as we know, this data should not longer than what? Longer than 105,000. Okay, 5,000. Then, okay, and then this length value should smaller than 105,000. Okay, and of course, in the Ether2, we need to carry different protocols, different upper layer protocols. Okay, so there's a type field in the frame, but now this field is replaced by the length. Then how to deal with the scenario that there's many different protocols, different upper layer protocols. So the IEEE use a sublayer. Okay, this is the layer 2 data link layer, and then this 3 means the MAC sublayer, and then developed ALLC sublayer, another ALLC sublayer, and then use this ALLC sublayer to identify what is the protocol used by the upper layer. That's the DSAP, Destination Service Access Point, and Source Service Access Point, and so on. They are only one byte. Okay. But as we know, this system is different from the Ether2. Okay. The Ether2 uses 2 bytes to identify what protocol is carried. So at the end, nowadays in real networks, the ALC layer is not widely used. So there's another package. Okay, another package. That means we use another format we called SNAP. SNAP. In this SNAP, the DSAP, SSAP are both A value. Okay, that means if DSAP and SAP is both AA, then means use the format of SNAP. Then there is followed by the SNAP. And in SNAP, they also inserted a type field. And this type field is compatible with the Ether2. Okay, with the Ether2. Ethernet 2. Okay, and this value can use the type value used in the Ethernet 2 frame. Okay, this is another frame, and nowadays this type IEEE frame is seldom used. Only the protocols developed by IEEE is use this frame, and usually the data we can, if we sniffer in the network, capture the packet in the Ethernet network. Usually, many packets, most of the frame is Ethernet 2 frame. Okay, and then the frame forwarding. Okay, now we have the frame. Okay, then if the host A want to send in the information, sending data to host B, then use the Ethernet frame. And in the Ethernet frame, we know first in the header there are 2 address, MAC address. Okay, the type figure out what is carried in the upper layer. Then the MAC address, we know it's a bone-in address of the physical address. Each network interface card, okay, in the computer must have an MAC address. And then when the host A sends the data to host B, then should fill in this field. The source should be itself, and then the destination should be the device host A wants to send the data to. in this scenario, it's host B. Okay, then when the data is sending to the media, then all the device connected to this media will hear this data. Okay, then the host receiving this data will decide if this data is sending to me or sending to others. Yeah, it's compared with the MAC address of the NIC card, of the NIC network interface card of itself, and then the address in this frame. If it's the same, then that means the destination of this frame is itself. If it's not the same, then just drop it. Okay, just drop it. Okay, then the MAC address. Then what's the MAC address? The MAC address is a unique address. Is a unique address of the network interface card. Network interface card. Each network interface card have a MAC address, and the MAC address is managed by IEEE. Okay, IEEE. That's each manufacturer, if want to produce the NIC, produce the network interface card, should apply a MAC address from IEEE. Of course, when the IEEE gets the application, then will assign a segment of MAC address. Of course, the IEEE use the one segment. Of course, the MAC address there's 48 bit long. Okay, so the IEEE only specifies the first 24 bit. This 24 bit is assigned to the manufacturer. Okay, this is called OUI. That's the organization unique identifier. Okay, then the manufacturer can use this segment. Of course, there's still another 24 bit. Then this manufacturer can assign a number to each NIC, each network interface card is produced. Okay, this is the MAC address. Okay,